So the derivative is 1 over the bracket times the derivative of the bracket. Now, the bracket is x plus x to the power of minus 2, so when we differentiate that we get 1 minus 2x to the minus 3. So 1 over, what I'm going to do is I'm going to make this x cubed plus 1 over x squared, and this is 1 minus 2 over x cubed and 1 over x cubed plus 1 over x squared times, I'm going to write this as x cubed minus 2 over x cubed. So what's going to happen then? Well, this x squared here will cancel with some of that x cubed, and what we then have is x cubed minus 2 on the top and x bracket x cubed plus 1 on the bottom. Now, this unusual power here should suggest that what we're going to do is to use logarithmic differentiation. So the natural log of y equals the natural log of x plus 1 to the power of x squared. And by the rules of logs, I can write that as x squared times natural log of x plus 1. Now if I differentiating natural log of y gives me 1 over y dy by dx. Now this is a product on the right hand side, so I'm going to differentiate the first and leave the second, and then leave the first and differentiate the second. There's not an awful lot I can do to tidy up the right hand side. What I'm going to do is to multiply by y, so dy by dx equals 2x natural log of x plus 1 plus x squared over x plus 1. Now multiplying by y, which is this here, I'm not sure what to do anymore with that. So what we want to do here is to replace x with negative x and then see what happens. So I have minus x all squared, sine of minus x plus tan of minus x all over minus x. Now the only problem part of this is the tan part. So minus x all squared is just x. Sine is an odd function, which means that sine of minus x equals minus sine of x. So that becomes minus sine of x. Tan of minus x, what do we do with that? Well, that's sine of minus x over the cos of minus x. Now, sine is an odd function, but cos is an even function, which means that cos of minus x equals the cos of x. So what do we have then? We've got sine of minus x is minus sine of x over the cos of x all over minus x. Now if I go to the top line and simplify, what I'm going to do is to take out minus 1. That gives me x sine x plus, well, I can take out that minus there, that just leaves me with tan x minus x on the bottom. The negatives cancel, and lo and behold, I have the original function again. Now, if f of minus x equals f of x, the function is even. We don't know how to integrate tan to the minus 1 of 5x, but we do know how to differentiate it. So what we're going to do is to rewrite the integral as 1 times tan to the minus 1 of 5x dx, and then apply integration by parts. So this will be v dash, we can integrate that, and we can differentiate this, so that will be u. U equals tan to the minus 1 of 5x, and u dash is 1 over 1 plus 5x all squared times the derivative of 5x which is 5 over 1 plus 25x squared. V dash is 1, and that means that v is x. So it's u dash, it's uv, so it's x times tan to the minus 1 of 5x minus v u dash. So v times u dash is 5x over 1 plus 25x squared. Now what we are going to do is to modify the top line. If I differentiate 1 plus 25x squared, I get 50x. So I'm going to multiply the top line by 10 and at the same time divide by 10 outside the integral. Now what I have here is, you've seen these before, it's f dash of x over f of x. So what we have then is x tan to the minus 1 minus 1 over 10 times the natural log of the modulus of 1 plus 25x squared plus the constant of integration c. Implicit differentiation. So what I have here is a product. Differentiate the first, leave the second, leave the first, and differentiate the second. I have another product here, so differentiate the first and leave the second, leave the first and differentiate the second. If I differentiate the right hand side, I just get 2. So dy by dx then, I'm going to take out dy by dx as a common factor from these two terms here, so that's x cubed plus x squared. So I have 2, and I'm going to take this term to the right hand side and this term here, so that's 2 minus 2xy minus 3x squared y. and finally get dy by dx on its own. So it's 2 minus 2xy minus 3x squared y all over x cubed plus x squared when x equals 2. Now, we really need a y value as well, so what I'm going to do is I'm going to sub x equals 2 into this equation. So that's 2 cubed y plus y times 2 squared, and 2 times 2 is 4. So I have 8y plus 4y equals 4. 12y equals 4 and y equals 1/3. So the point I have then is x equals 2 and y equals 1/3. What we want to do is to work out the equation of the tangent. So using the point 2 1/3, dy by dx equals 2 minus 2 times 2 times 1/3 minus 3 times 2 squared times 1/3 over 2 cubed plus 2 squared. That's 2 minus 4 over 3 minus 12 over 3, which is 4, all over 8 plus 4, which is 12. If I multiply the top by 3, I get 6. Multiply the top and the bottom by 3. So I have 6 minus 4 minus 12 over 36. And that then gives me 6 minus 16 minus 10 over 36, which is minus 5 over 18. The last thing to do is to work out the equation of the tangent. So y minus b equals m bracket x minus a. So that's y minus 1/3 equals minus 5 over 18 x minus 2 multiply by 18. So 18y, 18 divided by 3 is 6. It gives us minus 5x plus 10. 18y equals minus 5x plus 16. Partial fractions then, we have 4 over, it's necessary to factorise fully the bottom line, x squared x minus 4. So that's going to give us a over x. Now this here is a repeated linear factor, so the next term will be b over x squared, and then c over x minus 4. So 4 equals ax x minus 4 plus b x minus 4 plus cx squared. Choose the value x equals 0. First and last term is 0, so it's minus 4b. B then is minus 1. And x equals 4. First and second terms are 0. And we have 16c. So c equals 1/4. X equals 1. So I have 4. Now it's minus 3a minus 3b plus c. So 4 equals minus 3a minus plus 3 plus 1/4. So if I take the 3 and 1/4 over onto the left hand side, 4 take away 3 and 1/4 is 3/4, so 3/4 equals minus 3a, and a then is minus 1/4. So 4 over x squared, x minus 4 equals a, which is minus 1/4 over x, plus b minus 1 over x squared, plus c 1/4 over x minus 4. I could just maybe tidy that up, so it's minus 1 over 4x minus 1 over x squared plus 1 over 4 x minus 4. Now what we want to do is to integrate that. So I'm just going to modify this line here. First term gives us minus 1 over 4 natural log of the modulus of x. Now this gives us plus 1 over x, and this gives us 1 over 4 natural log of the modulus of x minus 4 plus the constant of integration c. We could bring together the two log terms, so I've got so it will be 1 over 4 natural log of x minus 4 over x plus 1 over x plus c. What we want here is the general term, so we're going to have 6r a to the power of 6 minus r minus 3 over a to the power of r. So we have 6r a to the 6 minus r. Now this last term here, this last part gives me minus 3 to the power of r. But I have a to the power of minus 1. This a on the bottom is a to the power of 1. It's a to the power of 1 on the bottom. But when we take it up, we get a to the power of minus 1, and that's multiplied by r. So that's a to the power of minus r. What we really want to do is to combine the two a terms. So that gives me a to the power of 6 minus 2r. Now, if it's to be independent of a, means that 6 minus 2r must equal 0, and r then is 3. So we have 6, 3, and it's minus 3 to the power of 3. That gives us minus 540.